Alright, so in this video, I'm going to solve the equation x to the power of x is equal to x to the power of 2. So to solve this, I'm going to start by dividing both sides by x to the power of 2. So these two cancel out, and I get x to the power of x over x to the power of 2 is equal to 1. Now I'm going to use the property a to the power of m over a to the power of n is equal to a to the power of m minus n. So this turns into x to the power of x minus 2 is equal to 1. Now I'm going to take the log on both sides, so I get log x to the power of x minus 2 is equal to log of 1. So this means that x minus 2 times log x is equal to 0. So now I get two equations. I get x minus 2 is equal to 0 and log of x is equal to 0. So this means that x is equal to 2. And if I take e to the power of both sides, I get that x is also equal to 1. Alright, so in this video, I'm going to solve the equation 2 to the power of x plus 8 to the power of x is equal to 10. So to solve this, I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x is equal to 10. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So I get 2 to the power of x plus 2 to the power of x to the power of 3 is equal to 10 because I switched the places of 3 and x. Now from here, I'm going to let 2 to the power of x equal to the variable y. So now I get y plus y to the power of 3 is equal to 10, and if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. Now, what I need to do is first find one solution of y, and then once I have that solution, I can find the remaining solutions. So to do that and find that first solution, I'm just going to test values of y. So we're going to start with y equals 1. So when y equals 1, I have 1 to the power of 3 plus 1 minus 10 is equal to 0. Well, 1 to the power of 3 is 1, 1 plus 1 is 2, 2 minus 10 is negative 8, which does not equal 0, so this does not work. Now I'm going to try y equals 2. So when y equals 2, I get 2 to the power of 3 plus 2 minus 10 is equal to 0. Now 2 to the power of 3 is 8, so I have 8 plus 2 minus 10. 8 plus 2 is 10, 10 minus 10 is 0. So this works, meaning y equals 2 is a solution. So what I'm going to do is divide y to the power of 3 plus y minus 10 by y minus 2, because y minus 2 equals 0, well, y equals 2 is the solution. So to do this, I'm going to use synthetic division. So I'm going to look at the coefficients of my numerator, and I have 1, which is the coefficient of y to the power of 3, 0, which is the coefficient of y squared. Remember, we're going order. 1, again, which is the coefficient of y, and negative 10. And just to let you guys know, the 0 is there because this is supposed to be y squared because we're going in order. But because there is no y squared, we put a 0 in front of it. And this is all with 2. And if you guys are still confused by this, you should look up a video on synthetic division. So I'm going to first start by moving down my 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 5. And 2 times 5 is 10. Negative 10 plus 10 is 0, so I have a remainder of 0. And I'm going to use these as my coefficients, so I get y squared plus 2y plus 5, meaning y squared plus 2y plus 5 times y minus 2 is equal to 0. So this is my equation, and I'm going to divide this into two equations. Y squared plus 2y plus 5 is equal to 0, and y minus 2 is equal to 0. So now for y minus 2 equals 0, I'm going to add 2 on both sides. So I get y is equal to 2. And for y squared plus 2y plus 5 equals 0, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get y equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5 all over 2 times 1. And this turns into negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. And because we have the square root of a negative number, we cannot use the solution of y, meaning we can only use y equals 2 as a solution. And remember, we're solving for x, not y. And we let 2 to the power of x equal to y. So I have 2 to the power of x is equal to 2. And the only solution to this would be x equals 1, because 2 to the power of 1 is equal to itself. So x equals 1 is my solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this video to your friends or family. Thank you. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 times 3 to the power of 33. So to solve this, I'm going to first rewrite 2 to the power of 22 as 2 to the power of 2 times 11. And I have this times 3 to the power of 3 times 11. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this turns into 2 to the power of 2 to the power of 11 times 3 to the power of 3 to the power of 11. Now 2 to the power of 2 is 4, so I get 4 to the power of 11 times 3 to the power of 3 is 27, so 27 to the power of 11. And now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this turns into 4 times 27 to the power of 11, which is equal to 108 to the power of 11. So this is my answer. Alright, so in this video, I'm going to solve the equation 3 to the power of x is equal to x to the power of 9. So, to solve this, I'm going to first take the power of 1 over 9x on both sides. And the reason I'm doing this is so I can get all the I can just get the numbers on one side and then the variables on the right side. So I'm going to use the property a to the power of m to the power of n is equal to a to the power of m times n, meaning these two multiply and these two multiply. So x times 1 over 9x, the x just cancels out, so I have 3 to the power of 1 over 9, and as you see, there's no variables on this side. And then on my right hand side, the 9's cancel out, so I have x to the power of 1 over x. Now from here, 1 over 9 is the same thing as 3 over 27. And if I have something, remember, in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So we can rewrite 3 over 27 as 3 to the power of 3 times 1 over 27. And now I'm going to reverse this property and rewrite this as 3 to the power of 3 to the power of 1 over 27. Now 3 to the power of 3 is 27, so I get 27 to the power of 1 over 27 is equal to x to the power of 1 over x. And notice how these two have the same forms, meaning x is 27. So this is my solution to this equation. Alright, so in this video, I'm going to solve the equation x to the power of x is equal to x to the power of 2. So, to solve this, I'm going to first start by dividing both sides by x to the power of 2. So then these two cancel out to get 1, and I get x to the power of x over x to the power of 2 is equal to 1. Now, I could use an important property of exponents that states that if I have something in the form a to the power of m minus a to the power of n, this is equal to, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, I have x to the power of x over x to the power of 2, and it's going to equal x to the power of x minus 2, which is equal to 1. Now, I'm going to take the ln, or natural log, on both sides. So I get ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns to b times ln a. So in this case, I can move x minus 2 to the front. So now I get x minus 2 times ln x is equal to ln 1. Now, if you didn't already know, ln 1 is actually equal to 0. So I get x minus 2 times ln x is equal to 0. And now I basically have two different equations. My first equation is x minus 2 equals 0. And my second equation is ln of x equals 0. So let's solve the first equation because it's the easiest. All I have to do is add 2 on both sides, and I get x is equal to 2. So this is one solution. And for ln x equals 0, to solve this, I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. E and ln cancel out, so I get x is equal to e to the power of 0, which is 1. So my two solutions to this equation are x equals 2 and x equals 1. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends and family. Thank you.